Find the moment of inertia of a rectangle 20 mm wide and 30 mm deep about a given axis AB, which is at a distance of 40 mm, 45 mm from its centroid. So here rectangle, here the dimensions are 20 mm width and 30 mm depth. So we have to find out moment of inertia about a given axis AB. So this AB axis is at a distance of 45 mm from its centroid. For rectangle, centroid is at center. So about this centroid, one axis is passing. That axis here we are assuming centroidal axis XX. So here you have to find out moment of inertia about axis AB. So this is AB and is it at a distance of 45 mm from its centroid. So this is centroid. From centroid to this axis is distance is 45 mm. So we have to find moment of inertia about this AB. So using parallel axis theorem, IAB equal to moment of inertia about centroidal axis IG. If you are mentioning G means centroidal axis, IG plus area into distance between the centroidal axis and the reference axis AB. So this is parallel axis theorem. So using parallel axis theorem, moment of inertia about AB equal to moment of inertia about centroidal axis. Here we are writing IG means moment of inertia about centroidal axis plus area into distance between these two axes, that is H. So here moment of inertia about centroidal axis. For a rectangle we know the formula. If the dimension is 20 mm, width is B 20 mm and depth is D, if you assume like this. So here H is 45 mm. So moment of inertia about centroidal axis is B D Q by 12. Central axis is here XX. So to this axis this 20 mm dimension is parallel. So here we are assuming B equal to 20 mm. So B D Q by 12 plus area B into D H square. So now we have to substitute all these values. D is 20 mm, D cube means 30 cube by 12 plus area B into D 20 into 30, H is 45 square. So if you calculate this, then you will get some 126 into 10 to the power of 4. So what are the units for moment of inertia? We know that simple moment of inertia means we know that area and some distance square for plane areas. If you have mass, then m into r square. So area units mm square, distance square units, distance means mm. So you have square, so mm square, mm to the power of 4. So units are mm to the power of 4. So moment of inertia about AB is, using parallel axis theorem we calculated, that is 126 into 10 to the power of 4. Moment of inertia units are mm to the power of 4. So coming to the second problem, here find moment of inertia of rectangular lamina of 30 mm wide and 70 mm deep about its centroid, and also find least radius of gyration. So here rectangular lamina 30 mm wide. So here it is B is 30 mm, depth is, here it is 70 mm, about centered, we have to find moment of inertia about centered. So center, so about its center we have drawing x-axis, and about its centered we are drawing another axis, that is y-axis. So now we have to find moment of inertia about its centered, means we have to find moment of inertia about x-axis and about y-y. So moment of inertia about x-axis equal to b dq by 12. So b means dimension 30 mm, depth is 70 mm, 30 into 70 cube by 12. So if you calculate, you will get some 857,500 mm to the power of 4. And moment of inertia about y. The formula is dbq by 12. So y-axis, along this y-axis you have dimension 70 mm. So at 70 mm here we are assuming d. So that letter comes first, 70 mm. d into b is, the remaining dimension is 30 cube by 12. So if you calculate, you get some 157,500 mm to the power of 4. So moment of inertia units is mm to the power of 4. So about its centroidal axis, we calculate the moment of inertia and also find least radius of gyration. We know radius of gyration k. So moment of inertia generally I equal to some area into distance square. So when the area is squeezed or concentrated to at one point, then at that time I equal to area into k square, because here now the rectangle, whenever this rectangle is there, then the distance is either it is y or it is x. But now the area is, this total rectangular lamina is squeezed to concentrated at one point. So when it becomes one point, then the distance is k only. K. So at that time radius of the measured distance, here we are calling radius of gyration. So here k equal to under root of I by j. But I means here whether should we consider ix's or iyy, depends upon the question. So he mentioned that least radius of gyration. So you have to calculate least value of radius of gyration. That means you have to take least value of moment of inertia. So moment of inertia about x-axis is 8,57,500. About y-axis is 1,57,500. In between these two, I by y value is less. So this is the least value. So that means k equal here under root of I y by j. So radius of gyration, least radius of gyration. So here we have to write least value, least radius of gyration, radius of gyration. So 1,57,500 by area is b into this 30 into 70. So if you calculate, then you will get some value 8.66 mm.